2010 ordinary level exam. As you can see in the top left hand corner, that's the 3D example that we have. This is just the paper sheet of it here. So we have a bus shelter, we have the front elevation, and we have the plan view. And on the left hand side of your screen, I hope to keep them there as long as possible, and I'm going to show you how I would approach this question. Alright, so the first thing we're going to start with is the information that's given in the question. The information is we have to draw the given plan. Okay, so this one here. I'm going to do it a little bit differently to what you see in the image. We're going to make a perspective drawing of the structure given, and the spectator point is 70 millimeters away from corner A. So the spectator, there's corner A, is 70 millimeters away from it, waiting for his bus. The picture plane is touching corner A, so therefore it's touching corner A, and the horizon line is 40 millimeters above the ground line, therefore saying that the spectator is 40 millimeters tall. Now what I would always advise is that we draw a little 3D graphic and we label up our 3D graphic. So the 4 points at the top of the bus shelter, we have 1 and 2 at the back, 3 and 4 up in the air, just like we have in the graphic here. And on the ground we have A and B at the back and C and D at the front. So we're going to return to that graphic in a few minutes, but we're going to use what we have on the page at the minute. So the first thing I'm going to do is use the plan view that you can see down here in the bottom left hand corner, and instead of drawing it the way it's given to me, I'm going to draw it in the top right hand corner of our page, and what I'm going to do is I'm going to rotate that around so that the long line is going to be horizontal. So we have horizontal and vertical lines, and then my spectator is going to be at an angle. Now what we know here is that this angle between that line and the spectator is 90 degrees plus an extra 30, which means from this front edge of the bus shelter we have 120 degrees. Okay, so that's the way I'm going to approach this question, and I'm going to start off with drawing the plan view. So according to the measurements in the question given, I'm going to draw a couple of construction lines. Okay, so start off with the back of the bus shelter. The measurement is 110 millimeters. So we start off with here and here, that's 110 millimeters by 60 millimeters. This is the plan view, remember. So we're looking down on top of it. Okay, and I'm just going to go over that in pen just so you can see it a little bit more visible on the screen. You do not have to do this in the exam, just make sure that you're using a heavy pencil. Okay, it's a line of importance, so therefore it should stand out. Okay, so now we have our plan view. What I'm next going to do is I'm going to find the angle of the spectator. So what we have is we have 120 degrees. So what we'll be doing is there's 90 degrees from the front surface of the bus shelter, and we need to come out an extra 30. So therefore that would be a 60 degree angle in comparison to, or 60 degree on a set square, or 30 degrees to the 90. So I'm coming 120 degrees from corner A. Now if you wanted to double check this, you can always use your protractor if needed. And what you should notice is we start with 0 here, and as we go around there's 120 degrees. Okay, so that is the position of our spectator at this angle, and we were told in the question that the spectator is 70 millimeters away. So I'll measure 70 millimeters from corner A, and I mark in the spectator. Now, at this stage what I would do is I would label my 8 corners. So if we look at our graphic here, okay, this back corner is going to be point 1 and A. So we have 4 points in the air and 4 points on the ground. Over here we have 2 and B. we have 4 and C, and we have 3 and D. So those 4 points of the plan view are 8 points in our 3D. So we've got them labelled up. The next thing what I'm going to do is I'm going to prepare my plan view and get that to completion in order to do my perspective view. So what we do for this is we're going to bring the furthest point on the left to the eye of the spectator, furthest point on the right to the eye of the spectator. That is the object that we need to see. Now if we were taking a picture of that, as you can see in the top left hand corner, we want it to fit in the middle of our screen. So we need to find and we need to look at this so that it fits equally in our screen. So we're going to look in the middle of this angle. And how do we look in the middle of an angle? Well, we simply bisect that angle. So we take our compass and we create an arc between the two furthest points, furthest on the left, furthest on the right, giving us point A and B. We then take our compass and we draw a second arc, and we draw a third arc, giving us the bisector. Now this bisector is what we call the center line of vision. That is the direction I am pointing my camera, CLV. I'm pointing my camera in the center line of vision so that the bus shelter sits in the middle of my photograph. What we need next is the picture plane. Now the picture plane is what the image will be cast onto. And again, if it's the screen of your phone, the screen of your phone is the picture plane. But in our circumstance, we were told that the picture plane is up against corner A. This being corner A here. So what I'm going to do is I'm going to take my set square and I'm going to line it up at 90 degrees. Or line it up with the center line of vision. I take my second set square and I'm creating a 90-degree line here, because on your phone, your canvas, your phone screen, your camera lens is going to be at 90 degrees to whatever way you're pointing it. So I'm going to slide this along the center line of vision until my second set square gets in contact with corner A. When it's in contact with corner A, draw it in there, and that is what we call our picture plane. PP and PP. Okay, and I'm just going to put the picture plane in a nice blue. Let's actually put it in red. No, we'll put it in blue. So we'll put it in blue. Our picture plane is now in blue. Now as we look at that object, okay, as we're standing here looking at the object, this side, as it travels, anything along that plane as it travels along is going to disappear as far as we can see, giving us our vanishing point on the left, and every object in that distance will end up disappearing at that point. And again, we can only see as far as the eye can see, giving us vanishing point left. The same with the front of the bus shelter. As that travels along and gets further and further away from it, it's going to end up disappearing till we can't see anymore, giving us vanishing point right. So what I'm going to do is, from the spectator's eye, I'm going to create those vanishing points. So as the spectator is looking in this direction, everything will disappear parallel to that surface, giving us VPL, and everything will disappear parallel to this surface, giving us VP4. And that is essentially all the work that we need to do with our plan view at the minute. Okay, I'm actually going to bring one more point. So I have the 3 corners brought to the eye of the spectator. I'm just going to bring the 4th corner to the eye of the spectator using my pencil. So now all 8 points of our bus shelter, or all 4 corners of our plan view, are brought to the eye of the spectator and are cast on the picture plane. So what I'm going to do now at this stage is I'm going to untape the sheet. Now this slows your question up a little bit, but what I experience and what I like to do is I like to do this because I find it keeps me getting the question as accurate as possible. So I'm just going to zoom out here to make sure we can fit it on the screen. Okay, and I'm going to line the picture plane up with my t-square. Making sure deadly accurate. And again, I'm battling just to be able to fit it on the screen. And we tape 2 pieces of tape again, making sure that it's stuck to the page, or stuck to the board. So now that's not going anywhere. Okay, so now our spectator is looking in this direction upon the object, upon the bus shelter. What we now need to do is, we've answered part A. This is our plan view. We now need to create the perspective of this object. Okay, and what I can do now is I can just lower this image out of the way a little bit. Now we can see what we're being asked. So we know that the spectator is 70 millimeters away. We've measured that. The picture plane is touching corner A. We have that in there, and the horizon line, which is the eye level of the spectator, is 40 millimeters above the ground. So what I'm going to do now is, in this empty space at the bottom of the page, the first thing I'm going to draw is my horizon line, and I'm going to draw this in blue. And I'm going to draw this in red actually, and I'm going to make sure I know that the object, the height of the object given to us in the question, we have 50 and 70. Now the height of my spectator is only 40, so some of this object is going to be above the eye line of the spectator. So I need to allow and accommodate for that. So I'm going to make sure that I'm at least 30 millimeters below S, which I am. And this is going to be what we call the horizon line, or the eye line of our spectator. So we have H, L. Okay. Just want to make sure we can see it. Okay. So we now have HL, which is the horizon line. We know that our spectator is 40 millimeters away from that, or is standing, sorry, on the ground, 40 millimeters below that. So therefore this is what we call our GL, our ground line. Okay. Again, we're just going to zoom in here a little bit. So, what we can see now on the screen, okay, is we have our perspective view going on here, and all of that is our plan view. What I'm now going to do is I'm going to transfer the plan view down to our perspective view. And the first thing I'm going to bring down is what we call our reference height line. And I'm going to do this in purple. So the reference height line is the true height upon everything is measured. Okay, so if we were to measure on this picture plane, this is the real height on the picture plane of any object. And as we can see, corner A is touching the picture plane, therefore it's going to measure the exact same measurement as is given in the question. Anything further away from that, as we know from perspective, will get smaller and therefore will look smaller in our perspective view, but it will still in reality be the same size. It's like looking down a street and seeing the lampposts that are further away from you getting smaller and smaller, whereas the one closest to you, if you were to measure it, would be the correct size. So this is what we call our reference height line. I'll just draw a little arrow to that and say reference height line. Okay, and on that we're going to measure any heights that are given to us. Again, these are true heights, okay, true measurements. So the measurements or the heights that are involved in this question are 50 millimeters and 70 millimeters. Okay, now 50 is only at the back and 70 is only at the front. So what I'm going to do first off is I'm going to draw my front surface, okay, or the true height of the line 1, 4. Sorry, 3, 4. Now, the first thing I'm going to do, okay, in order to draw this perspective view is find out where they disappear. So we have our vanishing points in our plan view. So all we're going to do is transfer VPL down and VPR down. Again, give them a label, VPL, VP. or. Now as this object sits on the ground, this here is the ground line, this is the bottom of corner D, and this is point D on the ground. It's going to disappear along the ground in this direction, therefore associated with VPL, so we'll draw in the ground line there at VPL. The same thing is going to happen along the front here at the ground. If we look at our drawing, we have corner D marked out, it's going to disappear going along C. So the ground point of that to find C is going to be from D, disappearing into the distance, and will disappear as far as our eye can see. So C, point C on the ground here, has to be somewhere along that line. Again, we're going to communicate our points with labels. So we have point D here. Now, we want to find the 4 ground points first, and then maybe find the 4 points in the air. So D, if I look at my plan view, D to A is on the ground, disappears to the left. This is the ground point, disappears to the left. A has to be somewhere on this line. Whereabouts on that line? So as this is our picture plane, our canvas, the lens of our camera, or the digital screen of the camera, as the A comes to the eye of the spectator, wherever it hits the picture plane is going to be brought down, and that's its location in the perspective. So A comes along, hits the eye of the spectator, this is where it is in contact with the picture plane, and as we bring that down, that will give us corner A. We now have the ground line of corner A, of line AD. That is AD of the bus shelter. We're going to do the exact same thing for C. So as C comes along to the eye of the spectator, wherever it meets the picture plane, we bring that down, giving us point C. There is the ground point, or the ground line of CD. We're going to do the same thing for B. As B comes along, B hits the eye of the spectator, wherever it meets the picture plane, bring that down, and B has to be somewhere along this line. But at the minute we don't actually have a location going towards a vanishing point here in plan, but we do know that BC is parallel to VPL, and I have point C, so what I'll do is I'll bring point C towards my VPL, and wherever this makes contact with my vertical line is going to be location of point B. Bring it along to the VPL, and make contact here, I have point B. And just to clarify that I have the correct point, we have A, we have D, we have C. AB is parallel to VPR, so if I go from A to VPR, I should hit the exact same point. And as you can see, I absolutely do. Going to VPR. Okay. Now that is our 4 points on the ground found. We now need to find our 4 points in the air. And as you can imagine, they're going to be directly above our 4 ground points. So we're going to find point 1. Here it is in our plan view, and we know it's somewhere along here, but what height is it? Now in the question, we know that point 1 is 50 millimeters above the ground. So I'm going to take my 50 mark. Okay, so we have our 50 height and our 70 height. With my 50 height, this is the true measurement of 50 here, and as it goes back there towards 1, it gets smaller. So we're going to do the exact same thing here. It's going to go towards VPL. So there's 50 going back towards VPL. Where does it meet the 1 line? Well, it meets it here. So therefore, that is point 1 at the height of 50 millimeters in perspective. There's the real height of 50 millimeters if it was up against our plane. We can get the true measurement of it then, but as it goes further away from the picture plane, it gets smaller, and that gives us our measurement of 0.1. We're going to do the same thing for 70. Now, as we know, okay, 0.3 here is 70 millimeters up in the air. It is touching the picture plane, therefore it's going to represent the true measurement. So this is 0.3. We're going to join 0.1 to 3. That is the angled surface of the bull shell. Now, in order to find point 4, we have point 3. It disappears towards the right, going parallel to the VPR. Therefore, we must do the same thing here. And as we do that, we're going to find point 4 by bringing it down from our plan view. There's two ways that we can do this. We know that point 3 and 4 are at 70 millimeters in height, so there's the true measurement of 70 millimeters. And as we get further away from the picture plane, it gets smaller and smaller and smaller. And that is going to represent the height of 70 as it disappears further away from us. And we also know that it's going to be above point C. So I can mark it in here knowing that it's above point C, but I can clarify and justify my answer by bringing point 4 to the eye of the spectator. Wherever it hits the picture plane, bring it straight down, giving me the exact same point. So I have 3, 4. Now the only point that I need is point number 2 at the back here, and again we can do that two ways. I already have it brought down from my plan view to my perspective view. We know that 2 and 4 are connected, so I can connect 4 to my VPL as I go from 4 further away, parallel to the VPL, therefore associating 4 to VPL, and that could find it for me. Or I have point 1, and as we go from point 1 to 2, that's parallel with VPR, all parallel lines, and I could find it that way. So I'm going to do it both ways to clarify my answer. 4 disappearing to VPL, 4 disappearing backwards, giving me point 2, and to justify my answer, I'm going to take 1 and as 4 is at the height of 70, so that doesn't work. So I have to go from the height of 50 that I have, which is here. And if I was to go through the 50 there, and from 50 to VPR, I'd hit the exact same point as. So apologies about that. I can't go from 4